Alright, so anyways, I guess on the introduction things, I'm Mike Lovell. I don't really feel like doing too much of an introduction on myself other than just, long-time lurker on the mailing list and done presentations a number of times in the past. And this particular topic was something that I found myself banging my head against the wall, and so I figured I would impart some knowledge. So through this, we're going to be kind of jumping around in history a little bit. To start with, 2011, I ended up buying a new laptop for myself, a ThinkPad X120 II. It was Lenovo's version of a netbook in their ThinkPad line. It was a cheap little system, pretty underpowered, but for just running simple desktop stuff like a bunch of terminals, which I have a tendency to do, it works pretty well. It of course came with Windows on it. And I went to install, some older version of Ubuntu, and things did not quite go right. And I wanted to dual boot, of course, because I still want to play my video games every once in a while. Got to get my Counter-Strike on. And so it not working right led me down a rabbit hole. And so I started chasing things. But now, to kind of understand what UEFI is and where it fits in, we need to go even back a little further in time. So, in the beginning, there was BIOS, and it was good. Well, kind of. But it worked. At least most of the time it worked. There were many times where it didn't quite work right. And BIOS is what we've had for decades. Literally, just a short acronym for Basic Input-Output System. It's the de facto standard for booting an x86-based system. The first incarnation of it was on the IBM PC back in the early 80s. Of course, it survived through various forms of the IBM PC. Lots of other vendors, when they decided they wanted to knock off the IBM PC, they, of course, knocked off BIOS as well, so that the same software that ran on the IBM PC could also run on their own knockoff hardware. It's responsible, so when you power on a system, there's the little bit of embedded code on the system that is in charge of getting the system actually started up. And so BIOS is the software that runs from power on until your operating system or your bootloader is running. It's usually stored on a small piece of flash that's attached to your system through SPI these days. Older ones, of course, connected through other older protocols. But it's these days essentially the same protocol that you would find on like an Arduino and whatnot, the SPI bus, and it's using that same type of flash that you could find for use in those situations. So there are several things that BIOS goes through and does during the boot process. The first thing, of course, you've all heard of, if you've heard of POST, the power on self-test. This is what goes through and checks various pieces of hardware in the system and makes sure that they're okay and initializes them. So for example, pretty soon after you get a system started, you're going to want to be able to use more than the memory that's inside of the level 1 caches of the processor. And so you have to initialize the memory controller so that you can get access to the main memory in the system, because those things have timings and whatnot that need to be set up. There's also other things like your interrupt controllers and DMA controllers. There's a number of things. There's your clocks and your timers and whatnot. Another thing that it does is it will load option ROMs. So, for example, if you have a network interface that has the ability to boot off it will load a small bit of code off of the ROM on that network controller into memory so that it can talk a standard interface or talk an interface to the network controller that's independent of the BIOS itself. It sets up a number of code and data pointers for the operating system. So, for example, the ACPI tables that describe the hardware in the system and what functions that the BIOS is going to provide to the system to do advanced functionality. It sets those up. It can also do simple hardware calls. So, for example, in the DOS days, DOS didn't necessarily have native device drivers for, say, a hard drive controller. So DOS would rely on the BIOS knowing how to read and write from its the disks on the system, and it would delegate those calls to some of the BIOS code. A few other things that it does. It attempts to load a bootloader from a different number of what I call protocols. You might find others using the term protocol in this context, but I don't know that you'd find all that many. But this is a way for the BIOS to find a bit of code to then execute when it's done. Classic examples of this are the MBR code block, the El Torito standard in the ISO 9660 standard for CD drives, the pre-execution environment for network devices, etc. The BIOS, of course, can also have a priority list to say, this is the order in which I want, or the administrator wants the system to try and boot from those. And then after the BIOS has found one of those bootloaders and loaded that into memory, it will then execute it, and the bootloader is then responsible for loading the rest of the operating system. And the rest of that boot process is discussed other places, and we're not Reddit, so we don't need to bash systemd it tonight. So, to review a little bit also about how BIOS will boot off of a disk drive or some kind of block device, we need to review a little bit about what MBR is, or Master Boot Record. This is the standard way to define partitions and boot code in legacy x86 PCs. It's a really, really simple method. Basically what it does is the BIOS will read the first 512 bytes off of the disk. The first about 446 bytes of it is actual code that it will execute as the first part of the bootloader. The next 64 bytes and change includes the partition tables for how the disk drive is split up into any partitions. And 446 bytes should be enough for anybody, right? Unfortunately, the 80s have passed. So this is a table I found off of Wikipedia that just gives a little bit of a description of what the MBR looks like. You can see there's not a whole lot of room up at the top there for code to actually execute a bootloader. And what most modern bootloaders do is they actually have just a very small shim inside that code space, because and then they have additional bits on one or two other locations on the drive. For example, with Grub, it has a little bit there, and then it will have another stage of code that lives right at the end of the MBR, because on most systems, the first partition doesn't start until several hundred K down the drive, the 63rd sector. If you're going by the old school device or IDE drive descriptions. And so there's this chunk of just unused space there. And so Grub will insert some code into there, which is the Grub 1.5, or a part of the Grub 1.5 loader, which then has the ability to read a file system, which will then actually read the contents of the remainder of the bootloader off of your actual file systems somewhere else on the disk. So, anyways, this is what we've been dealing with for a couple decades. There are a few downsides to this. A big one is the partition number, size, and identification strengths of Master Boot Record. You can only have 4 primary partitions. You can use logical and extended partitions given a certain number of constraints. The maximum partition size that you can have is 2 terabytes minus 512 bytes. So you're limited a little bit there. It's also difficult to extend. There's not, I mean, there kind of retroactively was defined standards, but it started off as just IBM developing something to do the work or do the job they needed that other people cloned, and eventually they did kind of standardize on stuff, but it was kind of a hodgepodge of different things. Supposedly a lot of it is written in assembly, which leads to the next one of not many have access to the source code for the different BIOS implementations. There's just a small number of companies that provide BIOS implementations, and they obviously don't share it with many people. There's a number of NDAs and whatnot, and you go to them to get any customization done. So, and it lacks a lot of other useful things, such as a way to store configuration data in a non-volatile storage area. BIOS does have the ability to store configuration data, but there's not really a standardized way of defining how to do that. And so each BIOS implementation might do it slightly different, and your software would have to keep track of all of those, which is untenable. So anyways, that kind of sets a little bit of the background. And now we're going to move up into the late 80s, where the Intel gods said, here's EFI, use it for it is better.
I heard you say 80s, you mean 90s?
Or 90s, yeah, the 90s. So I'll get into a little more specific on the time frame later. And the people ignored it until one big event happened in 2005. Apple decided that it was going to change all of its Mac systems to Intel processors. Apple decided that when they were going to make this transition, that they had a number of technical reasons and I guess and to some extent political advantages to not using traditional BIOS and go ahead and jumping to EFI. For one, they didn't have anything using BIOS. The previous PowerPC based Macs were using something called Open Firmware for their platform initialization. So they didn't have to worry about years of backwards compatibility. The other thing it did was if they made OS X only boot on EFI x86 systems, the number of other EFI x86 systems out there is very small. So the chance for bootlegging it onto non-Apple hardware was reduced considerably. Granted, people did it, but the procedure to do so was not something that was going to get out in the general public. It wasn't as easy as just grabbing the CD and dropping it in your drive. So that was one event that happened that changed things. There was another one, and the people decided they need more space. 2 terabyte drives in the late 2000s became readily available. I actually have a bad history with this particular model of drive, but that's a topic for another day. But people wanted to have individual volumes that were larger than 2 terabytes in size. And so MBR wouldn't facilitate that. So that was the second thing that really started to push vendors to making the migration to EFI, and actually more properly to UEFI. So UEFI stands for the Unified Extensible Firmware Interface. It was originally developed in the mid to late 80s. I think the first drafts of the specifications came out in like the 95, 96 time range. The first actual release was, I believe, about 98. It was developed by Intel as an actual, they started off with a written specification first and then developed to that specification. It was just called EFI by Intel, and they managed it up through version 1.10 in 2005. And actually the impetus for starting EFI was for the Itanium processor. The limitations of BIOS on some of the lower technical aspects prevented Intel from being able to use BIOS with the Itanium. So they had to develop a replacement anyways. And so they developed this standard. They actually developed it to be something that's supported across CPU architectures. Right now, it's supported for ARM, x86, IA64, and I think that's it at the moment. But after the 1.10 release 2005, Intel actually handed control of the UEFI specification to the Unified EFI Forum, and that's when it changed to UEFI. So, with having not having to worry about the backwards compatibility of BIOS, they were able to make a number of improvements to the firmware to give some advantages. What I think is one of the cool things about EFI is that there's a reference implementation provided in what's called the EFI Developer Kit, and specifically EDK 2 now. They're on the second version of it. And the vast majority of the EDK is open source software. It's developed on a SourceForge project, and you can get a lot of it either and use either a BSD or an Eclipse license, and it's pretty readable C. I mean, I spent some time the past couple days looking through some of it, trying to figure a few things out, and it looks a lot just like you'd find any other C code base. I mean, there are some differences with how it's going to be running at such low level on your system, but it's a noticeable improvement over trying to do things in assembly.
Quick question.
Yes.
It says that the early platform initialization is not open source. What kind of stuff?
So how I mentioned that early on, the system will do things like initialize memory controllers and DMA and whatnot. The code that does that is not open source.
Are there things in play to go full stack with that?
Yes, so there is an open source replacement for that code. It's called CoreBoot, what used to be called Linux BIOS, and that if they have support for your motherboard in it, you can actually flash that onto your chip, and I don't think they have it officially in the CoreBoot code base, but you can use the open source EFI code then as an EFI environment on top of that. Most people, though, I think when they're using CoreBoot, they'll just boot directly, or they'll have it go directly to grub or to the kernel or something like that, because most of the time they're looking at embedded environments. But if you have a Chromebook, it's using CoreBoot instead of BIOS or the vendor closed stuff. So, and Google's been pretty good about making sure that the CoreBoot code that they use on their Chromebooks gets upstreamed into the CoreBoot code base.
So there is an option if you wanted to go full pure play open source.
Yes, there is an option. It's probably going to involve a bit of work on your part, but it is possible to do. I haven't done it myself, but at least in theory, it's possible to do. So another thing is it supports the GPT partition tables. That partitions should not be plural, and a new boot protocol associated with those. It does also have what's called a compatibility support module, which allows EFI to boot as if it were running as a BIOS in a compatibility mode for older systems. But actually, the compatibility or the CSM module is actually optional, so it is possible that you could get an EFI implementation on a system that doesn't have the CSM, and so therefore it can't boot BIOS-based operating systems. I don't know of any systems myself that come that way, but just something to be aware of for a couple years down the road. I would suspect that in a few years we'll start to see some of them that are lacking that. Let's see, what was it I read? I think it's if you have the Windows 8. If you have Windows 8 or Windows 10 with one of the advanced sleep modes, that cannot the EFI firmware for that can't have the CSM installed. So those systems won't be able to boot legacy operating systems. Compatibility support module. So that's the BIOS emulation in EFI. a big thing is that it provides interfaces for reading and writing persistent configuration variables. And one place that, probably the most common place that you would see this is when storing information regarding the boot entries and the boot order itself. A few other advantages: it has a much faster initialization than BIOS. If you've gotten a machine in the past few years, you can definitely tell how much quicker they're able to go through the initialization phase compared to older BIOS systems. I don't think this necessarily plays into that fact, but if you use the EDK module or EDK kit to develop an EFI application, there's actually SMP support too. So you can do multi-process or multi-core applications even on the EFI at the EFI firmware level. There's a potential for graphical setup interfaces. So where you need to go in and change configuration settings on your system, you could actually have a mouse pointer and click at things and whatnot. Personally, I think that's more of a gimmick than anything, but some people think it's cool. It can give you cool readouts for if you're overclocking your system and whatnot.
Kind of what they said about the first Mac. I'm just kidding.
Yeah.
That's what
Well,
give me a command line.
it's actually not the first time that there's been a graphical setup tool for that. I mean, I've used LSI controllers over the years that have a graphical option ROM configuration utility, and I remember a couple Packard Bell systems from the late 90s that actually had a graphical BIOS configuration, but those were very one-off, whereas it's yeah.
It just feels wrong, right?
Yeah, it kind of feels wrong, but it's
bad. I mean, my system has it's an EFI system. It's got a graphical setup, and
yeah.
it's like I can't find anything for one.
Yeah.
No.
Well, some of the stuff's just not there.
Yeah.
You have to find
the advanced mode toggle and
classic
or the classic
PC or whatever mode.
Yeah.
And that'll get you to the normal one that you can actually find. Because I've gone through everything trying to find certain information and set certain settings, and it's just not there.
Yeah, and we're actually going to come back to that in just a moment. Let me just get through this next point. Another advantage, these days it generally does just work. If you've got Windows 7 or later, there's really good support for EFI inside Windows 7 and 8, and I'm assuming there will be in Windows 10. In Linux distributions for the past couple of years have had just like out-of-the-box support for it. They usually just work, especially if you stick to some of the bigger name ones. I know, for example, on my laptop here, I did a clean install of Windows 7, and then I installed Ubuntu 14.4, just the thing I would download off the internet, and it just did everything that it needed to write without having to prod it. So
Grub and everything on there, or
Mhm.
EFI has its own bootloader now?
so it does install Grub by default, and it puts Grub as the first item in the boot menu.
And then Grub boots Windows?
Yeah, it can. So Grub does have the ability to run another EFI application, and so what it will do is actually it will call the Windows boot manager that EFI application, which will then load Windows. So, and actually I do have the ability to demo that. So I can show you that in a little bit. So your mileage might vary on some of the older distributions or some of the more esoteric distributions. But in general, they should just work. So I haven't tried Gen 2 with it, so I'm not going to make any claims there. I think Arch does do a pretty good job of it, but I could be wrong.
It does.
It does. Well, there you go. Someone says it does. Anyways, now there are a few disadvantages though, and one thing that we were just talking about was there are some things left out of the specification. One of those big ones is what the configuration options are supposed to look like, or how they're described. So, for example, the boot order, it doesn't say what changing that should look like, or what the process for adding entries to it might be, or for removing entries. Some may give you the ability to add a boot entry from the setup tool. Some may not. In fact, I think the majority of them do not give you that ability. Some of them include what's called the EFI Shell. Some of them do not. So there's definitely the potential for the things at least having an outward appearance that are very different and not having an easy way to correlate what option is on one system is an option on another system. It doesn't have as much, real life testing as BIOS. I mean, BIOS has been around for for longer than I've been around. Whereas EFI has only really been in mainstream use for about the last 4 years. Apple has been using it longer, but when you compare it to BIOS, it still pales in comparison to the actual real-world use and testing that it's received. And there are still vendors that screw things up. There was one vendor that had a bug in their firmware where if you wrote enough EFI variables to fill up half of the space for the variables, it would brick the firmware. Your system would no longer boot. Another one where you couldn't delete variables. And so if you needed to change a boot option, which is a delete of a variable and then adding a new one, you couldn't delete the old one. And so you'd always have this boot option there, which if you ever change your system and that operating system goes away, you then have a boot option that you can never get rid of and you can't do anything with. There's a few other esoteric ways where vendors have managed to screw things up in different ways. So it's not a bulletproof system. There's still bugs that creep up. So anyways, now to talk a little bit about some of the things that there are in EFI and get into what some of the bits and pieces are. There's frequently something called the boot manager. This contains a list of boot applications. These are entries that contain the location of where a bootloader is stored. It'll point to a partition UUID, and this is actually more of a file system UUID. So when you format the file system, it gets a randomly generated UUID. The EFI firmware will have a reference to that UUID. So whenever it boots up, it will enumerate those and find that UUID. There will also be a path to the application and then a label or a name that gets displayed to the user. There's also a default path for valid devices that the boot manager can list, hard drive A, hard drive B, hard drive C, and even if you don't have a configured boot entry for that drive, there's a default path that it can take, so you can just say boot this drive, and it will try something. The menu option can actually show you pretty display names, so it can say something like boot Windows or boot Red Hat or Ubuntu, etc. Pixie, if you've been using that at all, it's relatively unchanged from the BIOS days. It still works pretty much the same. I haven't done too much with it myself, but the little bit of experimenting I did didn't look like there was much difference.
What is it? What's Pixie?
The pre-execution environment, network booting.
Okay.
So another concept to go with UEFI is you have the service partition. This is usually a small partition that's usually put at the very front of a block device that's somewhere in the hundreds of megabytes range in size. When I first started experimenting with EFI, installers would put it at 100 to 200 megabytes. These days, our installers are reserving about 500 megabytes for it, and that's where your bootloader is stored, or any other EFI applications that you might want to have on your system. They're almost always fat formatted. UEFI can actually understand file systems. Yay! It's not just read or write this block on the block device. So that's a plus. Unfortunately, it does seem that FAT is the only universally read file system on UEFI implementations, though it is possible to get other file systems in there. Though I don't know of any implementations that include that.
Is it partition agnostic, or does it only do GTP, or what?
It is possible to actually do EFI with MBR. I don't know of any. I've never tried it, and I don't know of any implementations that explicitly support it. So it might be possible that the ones I've tried support it. I just haven't given it a shot. But it is allowed according to the specification.
But what does it by default understand? GTP GPT only, or what?
So the firmware on your system, it may only support GPT, or if booting in a UEFI mode. Not so if it's booting in CSM mode, of course it has to have the MBR support. But booting in EFI mode off of an MBR partition table, in theory, is supported. I've never tried it.
Does FDisk understand?
FDisk does not understand GPT partition tables. It will, if you try to open a GPT formatted drive in FDisk, it's going to say, "Sorry, I can't do that." And then if you do a print, it will just say it's GPT. It'll just show like a single partition that takes the whole drive. Which is, I guess, one thing I can point out that I don't have in the slides. GPT writes its entries at the beginning and the end of the block device. And so if you have written a GPT partition table to a drive, and then you want to convert it back to an MBR, you need to use a tool like Parted or something else, so that, or write to both the beginning and the end of the drive to clear both sides of the GPT table. Because even if the kernel detects the one at the end and not the one at the beginning, it will still assume a GPT and go off the partition table it finds at the end.
Something corrupted the other one, go from there.
Yeah. So
Sounds like it's time to also learn how to use Parted.
yeah, which is actually really easy. I mean,
Yeah, it's just like FDisk type help and.
yeah, help and you're done.
Command.
This is
Yeah.
another-
MK part primary 1
Those
minus
are
1
nonsense when
done.
using FDisk and stuff like that.
So
If you really like FDisk, there's GDisk, which is just a GPT
form of FDisk.
disk.
Oh,
Yeah,
huh.
Hmm.
I didn't know
I
that.
think it's called GDisk.
Okay, so
Why
I don't have to
doesn't
learn Parted.
FDisk just learn both?
It's considered deprecated. Other than that, I mean, I don't know why it's considered deprecated. Kind of like why, in some developers' minds, ifconfig is considered deprecated. So, I mean,
So what?
the IP route to tools IP. So,
I held out on that until Cent 7, so I finally learned how to use IP.
oh really?
I still use NSW.
Was there something that prodded you to do that, or?
Cent 7 doesn't have ifconfig anymore.
Oh, it does. They don't even include ifconfig.
No.
Oh wow,
Well, they may include it, but it's not installed by default, so I was like, okay, fine.
wow. I didn't know they did that. That's a bit of a shocker. So anyways, let's see what else. Okay, so the default location for a bootloader. So if you haven't already set up a boot entry on your system and you have a EFI disk that you have on there with a bootloader, if it's at this location, EFI boot arch.efi, so like what you see on the bottom line here, and you tell your firmware to just boot this disk, that's the file that it's going to look for. So I think the Windows installers, they'll actually they'll write 2 copies of the Windows boot manager into your system partition, one at the default location and one at their own. And they'll add an entry into the boot menu for pointing to their own. So they set up the default one as a fallback in case something breaks. So that's something you'll want to keep in mind. And I'll actually be walking through some of the contents of the system partition in a little bit. So some useful tips. If you're dual booting, really make sure that you're running both operating systems in the same mode. Don't try to boot Windows in EFI mode and your Linux distribution in compatibility mode, or vice versa, or whatever. That's just going to confuse the heck out of things. So keep them at the same mode across whatever operating systems you're booting on your system. If you're unsure if your system is booted in EFI mode, there's a couple utilities you can use. If you're on Linux, you can just use EFI Boot Manager. It's a great command line tool for inspecting and modifying the boot menu. You can also look for the existence of the sys firmware EFI directory or the EFI vars kernel module. And if you have to use Windows, which I mean, I still use it for games, like I said. The MS Info 32 utility that you can get from just doing the Windows run command. It will tell you it has a line on there that's platform type, and it will tell you either BIOS or UEFI. So that's an easy way of telling which way you're going. All right, so now we get to demo time. Give me a second to resituate here because I need to be able to see both screens. So here I have a QEMU VM running. I'm using a tool called OVMF, or Open Virtualization something framework. I can't remember exactly what it stands for, but it's essentially the EDK2 kit compiled to run inside of a virtual machine. So that's what we have running here. So let me go ahead and log into this. This is just a simple Debian testing box that I have. And let me show you. Let's see, is that big enough?
Yeah.
Okay. Let me show you. If I just do sudo EFI boot manager, we get several bits of output here. For example, you can see on the very top what boot option we currently loaded into, what the timeout in the boot sequence is, but that doesn't really matter all that much. You can see what order it's currently configured to have for its boot options, as well as all of what the different boot options are. And if you look on where there's the 006 and 007, I actually have an entry that says Debian, another one that says Windows. So I can know if I do that, it's going to, or if I choose that option, that's what's going to boot.
So otherwise, would that say this is, disk 1, partition 3? Is that what it would be showing you there?
Not necessarily. So if you're using the default boot path and you're just telling the firmware to boot off of this disk, if you look at the line 3 there, or boot 0003, where it says EFI hard drive, so that's where it would go for that. And on that one, it's going to look for a partition on there that's an EFI system service partition. It may not look past the first partition. I don't know. I've never tried. I've always had it first. And it will just load the default loader from that location. So it doesn't necessarily, to have things where it's like boot from this partition or this partition, you would need to have boot menu entries, I believe. So let's see here. Let me get back down to my notes here. So how many of you have had a dual boot scenario? You've been in one operating system and you want to get to it. You want to reboot your system into the other operating system, but it's annoying that you have to sit and wait for the one to shut down so you can make sure you hit the right boot option. So we've had a few people do that. Here's a cool trick with EFI. So right now, if you look at the boot order up on the third line there, it says 006, 007. So it's going to boot Debian first by default, or it's going to load grub by default, which from there I could select Windows. But if I do EFI boot manager -N for next boot, and I specify 0007, it's going, you can see on the line right here, it said boot next, 0007. And so now, if I do sudo reboot, my system will go down and it will reboot. And without me doing anything, I'm getting into Windows. So I use this somewhat regularly on my workstation at home. If I'm doing something in Linux, which is what I do most of the time, and then I decide that I'm going to go play a game with friends, what I'll do is I'll tell the firmware to boot Windows next, just tell it to reboot, and then go off and get a drink or whatever while I wait for the system to reboot, and I come back in a minute and I'm at my Windows login prompt. So that's one of my favorite things about how I changed to using UEFI on my systems. So let me go ahead and show.
You see the weather? I'm on bias smoke. That's good.
So I'm going to go ahead and open up MS Info 32 here so you guys can see what it looks like. Right here it says BIOS mode UEFI. So if you're needing to find out if your Windows system is booted in an EFI mode, that's an easy way to check. I'm using Windows 8 in the VM here. Unfortunately, for some reason, OVMF doesn't work with Windows 7. So I had to try something that I'm not used to. Yes?
So in general, I get a new laptop and it's Windows, and all my usual tricks of getting dual boot mode, booting off a thumb drive and all these things don't seem the same, and searching the web, nobody seems to have installed Linux on this particular laptop. Is UEFI similar to BIOS in that they're just a standard set of tricks you do to dual boot?
Pretty much. Like I said, for most modern Linux distributions, anything in the past couple of years, it should just work.
Well, but I'm saying to get to where you can actually get a live CD up and running, or any of those.
So, are you talking about in terms of taking the ISO and turning it into something that you can actually boot, or?
So suppose I'm a Fedora guy, so I have a Fedora Live USB stick. I stick it in there, the thing doesn't boot off it. I have no idea how to get it to boot off that thing.
So what you could do there is try going into your system setup. Look around in the boot.
How do I even get to? There's no
So that's one of the downsides of UEFI. I mean, it doesn't say what key you're supposed to hit. It might be delete. It might be F2. It might be hold some 4-letter incantation. I don't know. I believe with Windows 8. Oh, and this is another thing. With some modern systems, they by default have the EFI in an EFI fast mode. So the EFI will go through all of its initialization and start loading the OS before it's even initialized the USB controller. So before you even have the ability to hit F2, it's already loaded the operating system. In cases like that, I believe there's a way to from Windows, when you do a shutdown, to tell it to go into the firmware on the next boot. I don't know the exact method of doing that, so you'd need to Google around a little bit for it. But I'm pretty sure there's a Windows option of doing it. Is it? Oh, I mean, we can probably try right here.
What's the equivalent to the system information on Linux to see if you're in EFI mode on a running system?
In Linux? So you can just run EFI Boot Manager, Boot MGR. If that returns some kind of readable output, then you're running in an EFI mode. Also, if you
is that required to boot, so you could end up in a spot where it's not installed, or?
So it is possible to use something besides EFI Boot Manager to control the boot order, but every Linux distro that I know of right now uses EFI Boot Manager during the installation process to actually set the boot order, and they leave that installed on the installed system. So I haven't had a UEFI system where that wasn't available to me. Yeah. Yep. If for some reason it's not, just do ls-mod to list your kernel modules. There's probably going to be one called EFI vars. That would also be a strong indication. And also, if you look in sys, the directory sys firmware EFI, and I can show you those when we go back to Linux in a few minutes. So I'm just making a quick poke around here to see if I see something that says to boot into the system firmware. I'm not seeing anything here.
Did you already look at the advanced options under boot?
Yeah, I just hit that and I'm not seeing anything in particular there that would tell me what it is.
Check the
So-
man page.
Huh? Yeah, the man page. Man, make Windows do what I want.
Yeah.
So anyways, that's that. Let me see what was next on there. So let me go ahead and now let's see if I can get Windows to actually shut down here. So let me do a restart. And since I didn't tell it to boot something different this time, it's going to go through its standard boot process, which should get us back into Debian without me doing anything.
And what this virtual machine, or what is it? This is QEMU. I've never seen it before.
Yes.
So like VirtualBox, just like a different flavor of it or something.
Kind of. Have you ever heard of KVM?
Yeah.
It's
Oh, well,
it's
no, actually,
it,
I've heard of a KVM switch, but no, I haven't.
the KVM virtualization technology. So that's Technically, it's the kernel virtual machine. It's a little bit of code in the Linux kernel
Okay.
that provides access to the CPU virtualization instructions.
Okay.
QEMU then is the user space process that takes advantage of that acceleration to do native speed virtual machines.
Huh. Oh, cool. Okay.
So
It predates
all of them.
Yeah,
It does.
It was originally a
It
full.
started as a full emulator, but
Yeah,
now
it was
it's
a full
it's
virtualization.
Full virtualization.
Wow.
And I believe VirtualBox uses it under pretty much
They-
everything.
The rumor.
Xbox on Linux is using QEMU.
Yeah, I heard that underneath it had it, or they ripped off some of the code base from QEMU is what I heard specifically.
I think everybody just uses it
Um,
as their
I don't think they actually just call that binary directly, because you can use VirtualBox without having QEMU installed.
right.
So
Yeah,
they do have the
include it somehow, but that's what it's.
yeah.
That's what it is under the hood.
Yeah, I've heard they reuse bits. I went looking through the VirtualBox code base to try to find those bits, and I couldn't find any. So, but that's what I've heard. I've heard that it uses it. I have been unable to definitively prove it, but that's the rumor I've heard as well. So anyways, as you can see, we got back into Linux here. So let me log back in. As far as the question of how do you tell. So if you can do an ls on this directory sys firmware EFI, that would strongly indicate that you're running.
If the file, so if you wanted to do this programmatically for whatever reason, you would just
You could just
-f sys firmware runtime, or what sys firmware EFI runtime or something like that.
yeah, you could just look for the directory sys firmware EFI. If you're running on a system booted in MBR mode, you won't even have that directory at all. So if you try to load the EFI vars module, which is what's providing the contents of this directory, that module won't even complete loading in an MBR or legacy BIOS environment.
I'm not seeing the EFI vars.
Yeah, it won't finish loading, so it won't even show up in your module list. So if I do lsmod grep EFI, you can see I have 2 EFI related modules here, which if I was booted in BIOS mode, those would not be there either. So you wouldn't be able to look for the existence of
I don't see
the.
I don't see the EFI vars on Central S7, but I do see the sys.
Yeah, so it's possible that they compile the EFI vars module into the kernel itself.
That's probably-
I would
It's
expect
not- that makes sense.
I would expect that more and more distros do that over time, considering that it's going to be much more standard. So, anyways, let me go ahead and break things here for a second. So let's see. I do need to look at the man page here. I forget the option. So I want to delete an entry. So sudo EFI boot MGR -b b0006. So I'm going to actually remove the EFI entry for my Debian bootloader here, and I think this might error. Nope, it didn't. So you can see now that I don't have Debian listed in there at all, and the first entry in my boot order is 7, which is Windows. So I'm going to go ahead and reboot again, and I'm going to show a really nice debugging tool that's available on some EFI systems. Not every EFI firmware is required to implement this module, but it is included here, which is an EFI Shell. So, I actually have a shell here. So it lists all the block devices that are available in my system, including the virtual floppy drives and CD drives. But up at the top, you can see there's this FS0, which is the first file system on the only hard drive I have. So if I change to FS0, and this is a very DOS-like shell, you can see they very much ripped off the appearance of DOS. But I can look inside here and wow, that blue does not turn up at all. But the first entry that got returned is a directory called EFI. And if I look look inside there. Wow, you can't show, those don't show up very well either. There's one called Microsoft, one called Boot, one called Debian, one called Refind, and one called Tools. And so inside of the Microsoft directory, there's another one called Boot, and this is all the contents of the Windows Boot Manager.
So this is that smallish file system you're talking about.
Mm-hmm.
And the OS could potentially drop files in there.
Correct. So in this case, this is the contents of the actual Windows bootloader. And so when I told the EFI to boot Windows next, it had an entry in here saying this bootmanager.efi file is what that Windows boot entry matches to, and so it loaded and executed that file.
Do you know what the contents of that file is?
It's a binary blob of data for Microsoft.
Okay.
So it's their bootloader.
All right, and it's just their bootloader. It's nothing else.
Yeah, and there's nothing really too special about it. I'm pretty sure they have a mirrored copy of it on their actual system volume, but I don't know for sure. Also, in theory, if you're using the Microsoft tools for editing the boot menu, those in an EFI mode, those will be editing the EFI entries.
What's it like for Linux? Would it be grub?
Mm-hmm. Yeah, so let me go ahead and so if I do a directory listing on this EFI Debian directory, there's grub x64.efi. And so if I just I removed Debian from my boot order. So if I just let the system go, it wouldn't even present me an option for booting Debian. But I can come to the shell here, and I can just directly run this application, and it loads my bootloader. So I can then select what's going on there. So that would let me get back into my system so that then I could fix things. If you notice here, huh?
That's pretty slick.
Yeah. And if you notice here also that grub has an entry for Windows. So what it'll do here is it will actually call back to that Windows file boot manager I showed you a moment ago, and it will execute that. There's also a system setup option here. It doesn't work with my OVMF VM that I have, but on my Dell laptop, if I reboot and I get to grub right here, it presents a system setup option. If I select that, it actually reboots and goes directly into system setup. I don't have to hit a key to actually go in there. So I would expect that on a number of physical systems that would actually work. So let me now show a slightly another way of doing this. I'm going to reset my VM here. Oh, I guess I didn't hit enter. And go back to my EFI shell.
How are you skating?
So in my case, I'm hitting F2 to get to the boot menu.
And that would be vendor specific if it's there.
Correct. It might be delete, it might be tab, it might be who knows what, Windows S or something like that.
And it might not even have this shell.
Yes. The Lenovo X120 that I mentioned that I got a couple years ago, which started me on this, it did not include the shell in the firmware. Though you can download a pre-built version of the shell from the EDK2 SourceForge project, put that on your EFI system partition, add an entry to your boot menu, and then you can select that, and it will execute it, and it's this exact same shell. So another cool thing that you can do is the Linux kernel actually has what they call the EFI Stub support now. So the kernel has support, if you compile it with the options, to be executed directly as an EFI application. So you don't necessarily need to have a dedicated bootloader for it. So if you look on this file system, or on the listing here, I have the VM Linux and an initRD that I copied from my Debian boot directory. So I'm just going to go ahead and execute this directly. giving it the kernel command line options. So I got to tell it what my root file system is. And so I can just execute this directly, and the kernel starts loading. No grub involved. Now, I don't know of anyone who's actually using that for a distribution type boot process, but it's something that you can use if you find a particular use for it.
You didn't want grub on the system.
Yeah. There are
security is there with that? Like you can set a grub password or a boot entry password. Is there security settings like that with EFI?
I believe so. I haven't used any myself, but I'm guessing that you can do some of the similar things that you could with BIOS. So I don't know that you could say booting this option requires a password, though you probably could write an application to do that. So
It's built into those hard drive firmwares as well.
yeah, there's the ATA secure bits that you could use as well. So anyways, let me log back in here, and let me fix my boo-boo. So let's see. I need to go back to the man page for a second. So I'm going to use the -C option to tell it to create a new boot entry. I need to tell it at least the label and the loader. So the label is what the boot option appears as in the menu. The loader is the actual application that's going to be used. There are a number of other things that you could specify, such as which disk, if you have multiple disks attached to the drive, which one it's going to use, and also which partition number. But I'm going to leave those unchanged because I don't need the defaults work in my case. So I want to create an entry. I'm going to give it a name of Debian. Oh, this is cap L. And I'm going to specify the loader. If you notice on the man page, it says defaults to //elilo.efi. You do need to make sure that you escape things properly so that it uses the right file name in the firmware. So it's going to be relative to the root of the EFI service partition. And if you're multiple directories in, you need to make sure that you escape your backslashes so that it knows them properly. So I'm going to specify EFI Debian grub x64.efi. So now if we look on our boot list, we have Debian again at the bottom as 006. And if you look at the boot order, it went ahead and put it first item in there.
If you didn't know that location and you were in Linux, is there a way to...
Yeah, so I was just about to show that. Most Linux distributions will mount the EFI service partition at /boot/EFI. And so I actually am doing a directory listing here to make sure I have the file name right. So here I did an ls on /boot/EFI, EFI/Debian, and I see it's the grub x64.efi file. So now for the big unknown. Hopefully this works. I'm going to reboot again. And hopefully it just boots Debian on its own. Whoops. That wasn't expected. Yeah. Let me go and reset.
Right.
Yeah, that's true. So I'm going to go ahead. Actually going through that, I'm going to leave as an exercise to the listener at this point, because I do want to show the last little thing I have on the demonstration, which is there are a number of other EFI applications out there that you can use as boot managers. One that was developed very early on after the Intel-based Macs came out was a boot manager called Refit, it's an EFI application that would be able to load. Then I believe it just loaded Grub or some other boot manager, but it has fallen into a defunct state, I guess. There hasn't been any new development done on it for several years, and there's this guy who I guess you could say forked it and renamed it to Refind, And so I installed Refind. I did that just by downloading the binary zip off of the website. And then there's an install.sh script in there that I just executed. So let me go ahead and execute it. And so now I get this thing that looks kind of like what a Mac bootloader was back in the day. So you can see here it detects the actual kernel that I have on my system, as well as the EFI application. And so I should be able to select this, and I'm back at Grub 2. So, and I think that is the end of the demo. So let me come back to the slide deck. So we're running a little short on time, so I'm going to have to kind of fly through this next part, which was EFI SecureBoot. I don't really have a whole lot to say on it, other than that it's not the giant SecureBoot itself was not the issue when the whole argument about it a couple years ago came up. There are malicious pieces of software that run at a BIOS level. They'll actually rewrite part of your BIOS and persistently infect whatever operating system you run on that system. And so to get around this, you need to have a chain of trust all the way from your platform initialization all the way up to your operating system. And so that's the problem that SecureBoot itself tried to solve. And it actually is a decent technical solution to a technical problem. The problem is the policy around controlling what's trusted inside the environment, who owns the certificates and keys that are involved. And that's what turned it into the big fuss that was heard around the communities a couple years ago.
Which one company?
Microsoft is the one who dictated a particular policy. So Microsoft said that any PC where they're going to apply for the Windows 8 logo sticker. So if you have a PC that comes with a Windows 8 Windows sticker on it, it had to go through the Windows 8 logo qualification process. Part of that process dictated that on x86 systems, SecureBoot had to be on by default. Originally, Microsoft didn't even provide they said the user couldn't even turn it off. And so in that case, how are they going to boot something that's not signed by Microsoft? So that's
where your subtitle comes in.
Yeah.
It's not an evil plot to take.
Yeah.
Okay.
UEFI itself is not the evil plot. SecureBoot itself is not the evil plot. Microsoft's policies around that caused a bit of a problem. But this is something that we really got to tip our hat to Red Hat for, because there were a few people involved there that raised their hands and said, wait a second, this isn't going to work for us. And they got Microsoft to change their policy for x86 systems so that for the qualification process, the user has to be able to turn off SecureBoot or be able to enroll their own signing keys so that they can control what is trusted and what is not.
Cool. Thanks.
But there are a couple of problems related to that. If you remember earlier, we talked about how there's not uniform configuration options inside of the setup tools of firmwares. Who knows what the options inside of the firmware are going to look like for disabling SecureBoot. It may say turn off SecureBoot here. It may say beware the dragons. It's you can't expect that the average user is going to be able to know what to do there. Granted, the enthusiasts are going to be able to figure it out, but we want to try to get Linux accepted by more than just us. So there's a few questions like who's supposed to own the platform key? According to current policy, it's the hardware vendor. So whoever made your motherboard is who's considered the owner of the platform, and it's their key that's in there, which is what the root of the trust for the other things. Microsoft's key is in there eventually, which is what is used for checking what's booted. But most distributions have figured out a solution to this, even with SecureBoot enabled. There were a couple different groups that on their own went to Microsoft and actually they paid a small nominal fee to Microsoft and submitted a bootloader to Microsoft and actually got it signed by the Microsoft EFI SecureBoot key. It's actually, I don't think it's managed by Microsoft directly. I think it's handled by VeriSign. But either way, they got it signed by that key. And so most modern, last year or two Linux distros should just work in a secure boot environment. I know that the most recent Ubuntu's do. I'm pretty sure that Red Hat 7 and derivatives will work. So it's not the big scary monster that people were afraid it might be. Microsoft apparently has actually been somewhat helpful on it, and so things have worked out pretty well. So it's not the scary monster. And that gets us to the end. Any questions? And while you guys are thinking about that, here's some resources. I highly recommend watching this video. Matthew Garrett is hilarious. Some of my jokes came from him.
Server class hardware now?
So server class hardware, it depends. I have bought some recent server hardware that is not UEFI and some that is.
Is it hit or miss? Is it?
It's going to depend. I would say kind of the rule of thumb is if you're talking about something that's an E5 class Xeon or an E3 class Xeon or newer, it most likely will be EFI. On the AMD side, it's probably a little later than that. I haven't used too much AMD or bought too much AMD gear the past couple years, so I can't really say there. So yeah, it's by this point any new stuff you're getting should be UEFI, but it is still possible that for legacy reasons they kept it as BIOS.
So it's coming.
Yeah, I mean I would expect that over the a short time period, if it's not already available, that it will be. So.
Well, at least in order to support, isn't it with the 2 gig or 2 terabyte drives?
Yeah, if you want to boot from a drive with a single volume larger than 2 terabytes, you're going to need EFI support. But on server class equipment, you're almost always writing some kind of environment where you have multiple partitions, and your boot stuff is a small one at the front of the drive. So you can actually have an MBR with a one partition configured in the MBR, and then also have a GPT partition table on top that has the same information for that first partition and then has the remainder. And so you could get to using GPT and different things, get a system booted with something larger. So it's just not as standard and takes some fudging with to get to work. So
I got a question for you.
Yeah.
I don't know, like a year or two ago, I took my Windows machine and made it a Hackintosh, so it's like dual boot Windows or Mac OS 10. And so, but somehow, I'm really glad you're talking about this stuff because it reminds me that I need to pay attention to the fact that I don't think I have any boot manager, or maybe I'm not understanding this, I don't think I have any boot manager on my computer, because if I don't have my USB stick that I made as part of the Hackintosh process plugged in, it just doesn't boot. And then it's using a program called Chameleon, I think.
Okay.
Do you know what that is?
I've heard the name and related to doing Hackintosh systems. I haven't done one myself.
So if I get it right, if my little USB stick gets fried, then I don't have a way to boot until I make, because that happened once and I had to go to my work Mac and
remake it.
Yeah. And so it's one of those like nagging tasks that I should have taken care of a long time ago. But I assume that I'd just be kind of, is that right to think that I just don't have any boot manager?
No, your EFI firmware does have a boot manager. It's just a matter of what it looks like. If you see anything that has your order of what you're booting from, it
just says missing operating system when it boots. What is it?
Well, no, I mean if you go into your system firmware, so like F2 or delete or something like that, there's going to be something in there that lets you choose the order of your boot devices.
Okay.
That's controlling the boot manager.
I gotcha.
So my guess is that the difficulty is in some way related to you doing the two different operating systems in different modes, like your Windows in BIOS MBR mode and your Hackintosh installation in UEFI. So that's what I don't know what all your system actually looks like, or
it's an older Dell Optiplex, so that's what people like to use for Hackintosh usually. So
how old?
Probably about 5 years old or something.
So it may not even have a UEFI on it.
Okay.
And in that case, the reason why you need the USB stick, I shouldn't speculate on, because I could be wrong in so many ways.
I'll probably pick your brain once we're done here a little more.
Yeah.
People probably don't want to hear about my.
Any other questions? All right. So thanks for coming and listening.